Good day everybody. In this lecture we will calculate how much energy we can save and recover applying anaerobic wastewater treatment instead of activated sludge. This table provides full-scale data of a beer brewing industry. Since beer is brewed in batches, the flow and the COD values as well as pH largely fluctuate over the day. Nonetheless, beer brewing wastewater can be excellently treated using high-rate anaerobic reactor technology. And in fact, with modern biotower reactors, the required anaerobic reactor volume for this wastewater is as low as 500 cubic meter, assuming a height of 25 and a diameter of 5 meter only. In other lectures we will learn how to dimension such a reactor. The total COD discharge of this brewer is up to 70 tons of COD per day. The graph shows the influent in blue and effluent in pink. We observe that the effluent does not reach to zero, and the reactor is characterized by treatment efficiency of about 85%. The bulk of the pollutants is thus converted into biogas. The effluent is either discharged to the sewer or is further upgraded, for instance, using an activated sludge plant. The wastewater has a total pollution load of 17 tons of COD per day, whereby 1 ton COD has an energy content of 13.8 gigajoule or a theoretical energy value of 3.8 megawatt hour. The amount of electric energy we can produce from this wastewater is 17 tons COD times 85% efficiency times 3.8 megawatt hour times 0.9 correction for the lower heating value times 40% of energy conversion efficiency in a modern combined heat and power CHP generator. Now this all equals about 20 megawatt hour electric per day. Since we treat anaerobically and we don't need aerators for the COD that we now convert to methane, therefore we may save up to 70 tons times 1 kilowatt hour per ton times 85% treatment efficiency, which equals up to 15 megawatt hour electric per day. So the total amount of energy saved is about 35 megawatt hour electric per day. Now calculating with an electricity price of 9 euro cents per kilowatt hour, this equals a financial benefit of over €1 million per year. In addition to energy savings, we will also reduce CO2 emissions linked to fossil fuel-based electricity production. The produced 20 megawatt hour per day from the biomass saves an emission of 15 tons CO2 per day compared to a similar production using coal in a power plant. Next to the recovered energy, also the avoidance of fossil fuel contribute to CO2 emission reduction. In this calculation, we save another 12 tons of CO2 emissions per day. In the given example, we save about 27 tons CO2 emissions per day. In principle, the CO2 emissions reductions that is achieved by using the produced biogas as a renewable fuel can be traded for carbon credits. At a formally agreed price of 20 euros per ton CO2, this would add another 110,000 euros per year of financial benefit. However, at present, the price of 1 ton CO2 is credited less than 5 euros per ton. This brings us to the state of the art with respect to the energy production potentials of current high-rate anaerobic wastewater treatment reactors. With applicable loading rates between 10 to 40 kilograms of COD per cubic meter reactor per day, the expected energy output ranges from 55 to 400 megajoule per cubic meter reactor volume. With this energy, we can potentially generate an electric power output of 0.25 to 2 kilowatt hour electric per cubic meter reactor volume. Concomitantly, CO2 emissions can be reduced by 1.9 to 40 tons of CO2 per cubic meter reactor volume per year. Now the listed values assume an 80% CH4 recovery from the influent COD load and 40% electric conversion efficiency by using a modern CHP. Now with these tabulated values you can quickly assess what an anaerobic reactor can contribute to the energy supply and thus financial benefits of your company, meanwhile treating your wastewater.